of overtime. Say my place at 9. She'd never stand for any lies. She's got an entree full of guys. I could sense her breath, a whole new feeling. Now she says she wants to call a meeting. We need to talk. Step into my office, baby. Wanna give you the job, a chance of overtime. Say my place at 9. I'm a slave to work. I'm only living when I walk amongst the office staff. I'll catch up with the office work. I'll be in bed by 9. My curtains drawn, my thoughts composed. I get to work on time. She gave me some dictation, but my strength is in administration. I took down all she said. I even took down a little red dress. We need to talk. Step into my office, baby. Wanna give you the job. I'm pushing for a raise. Been pushing now for days. My output is in decline. I was burned out after Thatcher. My banner I laid down with a sigh. Now a daughter found never catch her. I've got to change my ways. Dress for business every day. A sharp suit and a clipper tie. A big arrow pointing to my flight. Have you shaved for work yet, baby? Don't go where the boss is, baby. We need to talk. Step into my office, baby. Wanna give you the job, a chance of overtime. Say my place at 9.
All right, so last week we were looking at loops, and we're going to finish up with that today with a couple of exercises. But before we do that, remember that we were covering for loops and while loops. There are do while loops. Of course, you should read about those if you're interested. But as far as this class is concerned, we're only going to be covering for loops and while loops. We did a couple of exercises already on loops. We talked about nested loops. And then I ended with mentioning that there are some common pitfalls, very similar to the pitfalls, by the way, with conditionals that can be more or less detected if you use the wall flag. But consider the following piece of code. This is the first common pitfall that we generally see. Now, if you look at this really close, you'll see that it starts out at I is equal to 1. While I is less than 10, it's going to print it out and then increment it. So it's attempting to print out the numbers 1 through 10. But if you look really closely here, there's a character that probably does not belong. Let me just go ahead and cut and paste this. Oops, let's see, where are we? Let's go to CS, computer science, and then CSCE, there we go. So let's go ahead and compile this. No warnings at all, it compiles, great. Remember, I'm not using the wall flag here though. And so when we run this, All right, well, maybe it's just taking a little while. Now, we're probably, at this point, we're probably stuck in an infinite loop. Why? Let's again walk through this line by line. Let me go ahead and indent this properly. All right. So, I starts out at 1 here. While I is less than or equal to 10, do what? Nothing. Right? Remember, you can have empty statements. There's an empty statement. Do nothing. Do nothing. Do nothing. So, while I is less than or equal to 10, do what? Do nothing. Did I change I? Nope, it's still the same. So, it's still 1, do nothing. Still 1, do nothing. Still 1, do nothing. Remember, how do I kill this? Control C, right? So, the problem here is a misplaced semicolon, right? And the solution is, again, to use that wall flag, right? A semicolon is misplaced. It makes the loop body empty, and thus you'll be caught in an infinite loop. A Control C kills that program, at which point we can go back and make sure that we are using the wall flag, and it'll tell us about that. Warning, this while clause does not guard. It's the exact same message when we had a misplaced semicolon with respect to an if conditional. Right? And so there's something going on here. It's perfectly valid syntax. You can do nothing, right? And it'll let you do nothing. But of course, it's not what you want. Okay? So remember to always use the proper linter and always use the wall flag. Next, consider the following piece of code. There we go. So again, it's syntactically correct, but there's something missing here. What's missing? So remember, loops have three basic, four, but three basic control structures for it. An initialization, you got to start somewhere. A continuation, how do you know that you keep going? And you need an increment, or you need to work towards that terminating condition. Am I working towards that terminating condition? No, I've omitted the I++. Predict what's going to happen with this piece of code when I try to run it. Even with the wall flag, it's not going to catch that, by the way. So what's going to happen? It's just going to keep printing 0, 0, 0, 0, 0, 0, 0, whatever I started from. Once again, kill it with Control C. Right? Again, this leads to an infinite loop, so you always need to be making progress towards that termination condition. Two more. One of them common, one of them not so common. Right? Consider the following piece of code. I is equal to 0, while I is strictly less than 10, printed out, and I++. Yeah, there's no brackets there. I wonder what happens in that case. Let's find out. I'm interested. Oops. Now, normally I would want to indent, but indentation, indentation is meaningless in C, in Java, in most programming languages. If you're coming from a Python background, if you've ever had any Python before, you'll note that indentation is super important in Python. But then you get yourself into big trouble because sometimes you use 3 spaces, sometimes it's a tab, sometimes it's 2 spaces, right? And all of those things are different in Python. Here, it looks kind of like Python. I've omitted the brackets here. So what's the interpretation? What's going to end up happening here? I'm going to go ahead and compile it and run it. Exact same thing as before. Let's understand that while it's running in the background here. I initialize it to 0. While I is strictly less than 10, do the next available thing. Because there are no curly brackets, the next available thing is only the one line on line 15. And so it's going to simply print it out, print it out, print it out, print it out. Even though this is indented, it is not part of this code block right here. In other words, you can omit the curly brackets, but in general, it is a very bad idea to do so because you'll have this problem.
Why does it ignore the implementation?
Because it's not part of the while loop. In fact, let's go ahead and kill this and try to compile it again with the wall flag on, and it'll say, wait a second, it does not guard, right? This statement is, but it's misleadingly indented as if it were part of the while statement, but it's not. Without those curly brackets, it only does the next one single available thing. There's our while loop, right? There's our while block. This is completely different. This is something down here after the while loop is done, right? So always make sure, even though it's not necessary in some instances, just don't get into the habit of not writing the proper curly brackets. Always write the curly brackets. That's really just bad style, right? It is best practice to always write your curly brackets even when you don't need them. Okay? One last one. And I used to be able to do this and people knew what a zune was, and then it got to a point where nobody knew what a zune was, and now some people do know what a zune is because it's featured in one of the Marvel movies, right? As a joke, here's an ancient piece of technology that nobody ever used. Well, zune was basically an iPod, right? iPods, music iPods, an MP3 player. It was a rival to the iPod. Never as popular. The reason that you'd want a zune over an iPod is because it was $100 cheaper, and it had a radio. But in any case, I had a zune, and my zune was affected like this. On December 31st, 2008, every zune in the entire world froze for exactly 24 hours. 24 hours later, it was fine. What happened? Well, first of all, what is 2008? Now that you've had some experience coding is leap year, right? Or is this a leap year or not? You tell me, was 2008 a leap year? Yep. How many days are there in a leap year? 366. So on December 31st, that was the last day of the year. That was the 366th day of the year. Here's some actual code that was in a subsystem in the Zune software. Right? So while days is strictly greater than 365, so in other words 366, this is true. We jump into this loop. If it's a leap year, it is, 2008 is a leap year, so this block gets executed. Not this block, but this block gets executed. Okay? If days is strictly greater than 366, is it? Nope. It is 366. It is equal to 366. So this block is not executed. So where do we go? Right back up to the top. Was days or year or anything changed? Nope. It's 366. It's still the 366th day. It's still 2008. So we repeat this process over and over and over again until the next day, 24 hours later. It becomes the 367th day of the year. So this is true. It is still a leap year because we haven't changed the year. But now the days is 367, which is strictly greater. We subtract 366, so now it's the first day of the year. We add one day to the year. Now it's 2009, so it's not a leap year. We break out of this loop, and everything is unfrozen at this point. All right? This was an actual bug that was published after they found this out. Now, who cares if people can't listen to their music on a third-rate product for 24 hours, right? But there have been plenty of bugs like this where, what is the solution, by the way? Or what should have been the solution? Greater than or equals to. In other words, one character. There have been plenty of bugs where one character, it was off by one character, and it cost way more than 24 hours of not listening to music. There are 2 Mars rovers that predate maybe most of your lifetimes that were crashed for various bug reasons. One of them was a failure to convert from metric into English. Why the subsystem was using English measurements, who knows? Nobody is allowed to work with NASA if they do that anymore. That was one of the consequences of that. But $100 million, $200 million Mars rover crashed because they thought they were going a certain miles per hour instead of kilometers per hour, right? Stupid bugs like that. There's a bug that existed in the iOS system for 15, 20 years that circumvented every single security measure that they had in their SSL layer, their secure socket layer. Why? Because somebody forgot a colon somewhere, right? It was called the go to fail button. There have been plenty of examples like this. And this is where you need to realize that computer science software engineering, whatever you want to call it, is completely different than any other science and engineering discipline. Because if you are a civil engineer and you design this, you perfectly design this bridge, and it's built perfectly, except for one thing. One bolt is out of place. Is it likely that that bridge is going to collapse? No, it's just one bolt, right? There's some tolerance built in there. There is zero tolerance with respect to software. It's right or it ain't, right? And this one ain't, right? One semicolon, one equal sign out of place, and the bridge does collapse. So keep that in mind, right? When you're frustrated that something won't compile or run, just remember you're not working on medical software. You're not working on a $200 million rover. The consequences of that are just a little bit extra time of going back and fixing it instead of crashing a rover directly into Mars. Right? Or another one was, I think it was insulin or a medicine level, and it killed several dozen people because it was giving way too much insulin or not enough. I forget which one it was, but it was off. Yeah.
Have you heard about the CARE Act 25 incident?
The what?
CARE Act 25 incident?
Is that the commodities trading incident?
I think it was like a radiation machine.
Oh, yeah, the radiation machine. Yep, that's another one. The one that I thought that you were referencing was that somebody left off their decimal place was off, and it caused this automated trading program to instantly buy billions of dollars of stock, which caused a price increase and a market crash because all these other programs then started responding, and that's not allowed to happen anymore. Or who knows? As people are fond of saying, the world runs on Excel. So that's how precarious the world actually is. All right, with the rest of our time, let's go ahead and do an exercise. What I want to do is I want to do something that's going to be very similar to what you're going to do in your hack this week. Not your lab, but your hack. We're going to compute a loan amortization table. Now, I don't expect you to know anything about finance. I'm going to tell you what it is along the way. But generally, I do understand that most people understand that there are loans. You can borrow money from a bank. You have to pay them back. You do have to pay them back. And you have to pay them some interest. So, for example, if you took out a $10,000 loan to buy a used car, right, they might charge you 5% interest. And the terms might be a 5-year loan. So you have to pay it back over 5 years. Generally, you pay them back monthly. And since there are 12 months in a year, that means that there are 60 payments total. Our finance folks, actually our mathematicians, not the finance folks, but the mathematicians have come up with a formula that tells you how much you should be paying each month. That's called the monthly payment. It's times the rate, which in this case, the rate is 5%, which is modeled as 0.05, not 5. That would be 500%. Do not ever take out a loan on 500%. Over 12 months, right? So you don't pay that. That's an annual rate. And then monthly, it's going to be divided by 12. So that's our rate there, right? Times the principal. In this case, the principal is the amount that you originally borrow from the bank, $10,000. Divided by 1 minus 1 plus the rate, same rate as before, raised to the power negative n, where n is the number of payments, right? Once you have this, then you have a monthly payment, $188.71. That's how much you're going to be paying over the entire loan in order to pay it back in that 5 years. Now, if you take out your calculator, my calculator is going to be Wolfram Alpha, and you go $188.71, I pay that 60 times. That's not $10,000, is it? That's $11,322.60. That additional money, that $1,322.60, that's the interest. That's the cost of the loan, right? That's the amount that I'm paying back each time to the bank in addition, right? Now, an amortization table looks something like this, okay? The first month, we owe $10,000. But we're not going to pay $10,000. Otherwise, if I could pay $10,000, I wouldn't take it out a loan. Instead, we're going to pay $188.71. Now, part of that goes to paying down the loan. Part of that goes to interest. How much goes to interest? Well, my interest was 5% over 12 months. And so my interest rate on a monthly basis is 0.0041 dot, dot, dot. If I multiply that by the amount that I owe in that first month, $10,000, what do I get? $41.67 and then some fractions of a penny here. In other words, $41.67 if I round it properly. That's where, that's where this comes in, $41.67. That goes to the interest. If I take that off of $188.71, then I have a remainder of $147.04. That's how much goes to the actual loan. So from $10,000, I've paid down only $147.04, giving me a new balance of $9,852.96. That process repeats for the second month, the third month, dot, dot, dot. I don't have all the months here. Instead, I'll have an ellipsis telling you that there's more down below. I'm not going to print it out because there would be 60 lines there. You get the idea, though, okay? So along with me, help me out. Let's start writing our program, okay? Now, I've got a lot of inputs here, right? For now, I'm just going to simply hard code them to this particular example. $10,000 at 5 years, 5% interest. I count 3 variables at least there, right? Double principal, right? And it is principal, not POW, there we go, is equal to $10,000. Right? The rate, that's called the APR, annual percentage rate, is 5%, 0.05%. There we go. Okay. Is there a better name for APR? Avoid abbreviations if you want and say annual percentage rate. Percentage rate. Now, if you were in a domain-specific kind of situation where you were actually employed at a bank, everybody there is going to know what APR is, right? If it's well understood, then maybe you have an argument for using an abbreviation like that. But for us, no, I want to keep in my mind what that actually stands for. It's an annual percentage rate, not a monthly percentage rate, not a generic rate. There's my annual percentage rate. Okay? What else was there? The number of years that you're going to take to pay it back. Now, you can have 5.5-year loans. Weird. You can have 5 and, whatever, 5.23, I don't know how many days that would be, years. But for the vast majority of financial applications, the number of years is going to be a whole number. 5 years, 10 years, 30 years, 15 years, right? 30 years is, at least in the United States, 30 years is basically the max, and that's for a mortgage. But in some countries, they do, like in Japan, I think they have 100-year mortgages, right? Where you're paying it over 100 years. It's multi-generational, right? Our years is going to be 5 here, right? Okay. There's our setup. Now, my next problem here is going to be to compute the actual monthly payments. I want to get $188.71 out of this. So remember that, or I'll put it off to the side here and we'll come back to it. But otherwise, it's here. I'll just come back to it. Rate times the principal over that stuff. So let's go ahead and compute that. P is equal to rate times the principal, right, divided by 1, and then what was it? Minus 1 plus rate raised to the power negative n. Now, there are lots of problems with that. You're going to help me fix them. Right? The first problem is this P right here. Right? Now, if you're in a financial application, if you are in math class, X, Y, A, B, C, right? Those are perfectly valid variable names because they don't know what they're talking about, right? It's just they're thinking so abstractly that they don't even know what their variables are representing. When you actually graph something, the x-axis and the y-axis, they end up having labels because now you're actually labeling something that actually has some meaning. We are in code here. P has no meaning to us. What is P? It's the monthly payment. So if it's modeling the monthly payment, what do you think we should call that variable? Monthly payment. I like that. monthly payment. There we go. Now, is there a variable called rate? Remember over here, the rate was actually a monthly rate, right? The annual percentage rate divided by 12. Yeah, okay. Well, I could hard code that. Let's do that at first. I could go ahead and say, what is the annual percentage rate divided by 12? Be careful. Is there an integer truncation issue here? Generally, yes, but one of them is already a double, so no worries there. If you're really worried about it, go ahead and add a 0.0, and you're fine. You were fine before, though. Right? And I will take that and replace that over there. Getting pretty long there, right? And also, magic number, 12. We all know that there are 12 months in a year, right? Maybe we'll have, I don't know, metric years in the future, and we'll only have 10 months instead, right? Although there are 13 lunar cycles in a year, so maybe that's 13, right? Put that in a variable, right? You're not paying by the variable. Monthly rate. Monthly rate. There we go. There we go. There's my monthly rate. In fact, I have an even stronger argument here for putting this into a variable. Why? I'm using it once, twice, and in fact, later on, I'm going to use it thrice or 4 times. And if I'm using it that many times, put it in a variable that you have a label for instead of an expression. Okay? All right, any other problems here? Monthly rate times the principal. Be consistent on your white space. 1, there's no getting around that. 1 plus monthly rate raised to the power negative n. Can't do that. This has a meaning in C. It will compile, but it will not give you what you want. It's a bitwise exclusive OR operator. If you get into bit twiddling later on, when you're actually doing like systems programming, that'll become meaningful, right? It's a little way that you can actually access individual bits in an actual byte, all right? So a byte is 8 bits, and if I only want this bit over here, I'm going to have to mask it and bit twiddle it and screw around with the actual bits. We're not doing that in this class, though. So how do I raise to a power? X raised to the power y is going to be pow, exactly. Why is it not power? Because 60 years ago, they were paying by the character. There we go. And I need a comma here. All right, oops, there we go. And that will close off my pow, and so I need to close off the denominator with yet another one. There's no problem with negating something. Whatever n was, it is now negative. But do you see an n variable here? Nope. So what does n, what does n stand for again? This is the power and the whole point of having good variable names. Everything should be self-documenting, right? A comment like this, declare your variables. That should not be a comment, excuse me, that is in your code. Now that you're in week 4, you know that these are variable declarations. If you come back a year from now, you'll definitely know that these are variable declarations. That's not a useful comment. That is clutter. That's what we call cruft. All right. What is cruft? I don't know if it's Yale or Harvard, but there was a building called Cruft Hall. Let's just say that it's at Harvard. There was a building called Cruft Hall, and nobody used it for classes anymore. So what did they do? They took all their garbage, like a broken overhead projector or an obsolete machine or something like that, and they threw it into Cruft Hall because that was cheaper than hauling it to the dump. What eventually happened to Cruft Hall? Filled up with garbage, right? Don't do that. Don't fill your code up with garbage. Take out the cruft. Take out the trash, okay? All right, so n, what was it again? It's the number of months. Int number or num months. All right, there we go. And that's going to be years times 12. Right? Now I don't have to remember that there are 12 months in a year. Right? Num months, there, that's my variable. Right? That's exactly this over here, but translated out to code. Ad hoc testing, right? Should I go and write the rest of the program without making sure that what I've got so far is correct? Probably not. I want to do a sanity check here. Let's just make sure that I've actually computed the monthly payment correctly first. Printf, monthly payment. I had to correct a bunch of spellings in one of your future hacks because they were misspelled in the solution, and so it kept rejecting my solution or another solution because they were spelled correctly in that. So I had to go back and do a bunch of stuff. So this is $1, and I'm going to go ahead and go with a %F for now to show you monthly payment. There we go. And let's go ahead and compile it. Oops. I've got the incorrect number of stuff here. There. That'll work. Or I could put more parentheses there. I think that that's it. Okay. Good. Now, what am I forgetting to do here? It's complaining about the math library. Right? POW is in the math library. So I need to link in the math library. And now it runs. So if this is correct, I should expect, what again? $188.71 for my monthly payment. Almost dead on. Are those fractions of a cent going to be a problem? Yeah, it doesn't, you know, there in the real world, if you were doing an actual financial application, I'm sure that there are a whole bunch of, FTC or banking regulations that would come into play that say exactly what should happen to those fractions of a cent. For our application, though, I don't want them because fractions compound. And eventually, at the end of the loan period, we're going to be off by a penny or either in our favor or in the bank's favor, right? So let's go ahead and get rid of those first of all. Anybody have any ideas for how I could get rid of them? Oh, say what again? Add 0.2? What do you mean? Like, like this. Yeah. Good. All right, let's do that. But before I do that, let me go ahead and copy and paste that and not go out to 2 decimals. Oops. There we go. So that took care of it for the purposes of printing, but was the actual variable value changed? As witnessed by the second print statement, no. So I want to actually change the variable. I want to round monthly payment to the nearest cent, ... Okay? Guess what do you have in the math library? Round, right? Monthly payment. Right, there we go. Let's see if that made a difference. Yeah, warning. We should be listening to that warning because that's the intentional bug that I just did. Right? Let's run it. Didn't do anything. What was the warning about? Statement with no effect. If you called square root of 2, right, that's going to compute 1.41 blah, 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 blah. But what happens to that 1.41? Nothing. What do you got to do? You got to assign it to a variable, right? This doesn't do anything to the monthly payment. It only takes it as input, computes around the rounded value, and then gives that back to you. So if you want to store that somewhere, you need to store it in your variable. Monthly payment is equal to the rounding of the monthly payment. And remember, having monthly payment on both sides, that's mathematically weird, right? Because that would be algebra, but this ain't algebra. Right? This is programming. I'm taking the result of the thing on the right-hand side, and I'm putting it into the variable on the left-hand side. Let's find out if that fixed all my errors. Certainly rounded. We went from 188.71 and some fractions of a cent to 189. What does that tell you about the round function? Rounds to a nearest whole number. That's not what I want. What I want is, I want this to go to 188.71. Right? Now the round function is operating right here. Right? That's what I want. So somewhere in between, I need to get from there to there. Well, if it's only going to the first whole number, I'd really like it to be over here instead. Well, if you want your period to be over there, you can make it so. What did I just do? I just moved the floating point over. I floated it over. Right? That's where we get the term floating point number, right? Think about this in scientific notation. What is 188.71 and change, 23, whatever, whatever, whatever? That's equal to 1.887123 times 10 to the second. You've all seen scientific notation before, right? From basic math class? That's exactly how floating points work, right? It floats the point over to some standard, right? It floats it over here. And then, of course, to correct for it, you have to multiply by 10. Well, if I want to move the floating point number over here, what do? Multiply by just 10? 100. Right? And if you want to, you can go 0.0, but you don't need to. Okay. There. What was I doing in comments here? I was whiteboarding. You should be doing that on a piece of paper, right? We still work with paper. Paper is not dead. Paper is not obsolete, right? If you want to, you can use your iPad instead, right? Or whatever, right? And if you want to be fancy about it. Right? There we go. Okay. Almost there. It certainly does round. It moves things over. But my first monthly payment is more than the entire loan. Is that right?
So then after that, you go.
Okay. After that, correct it by dividing by 100. Right? 0.0 if you want, but it's not necessary.
Probably add another bracket just to be safe.
Oh, where?
Like, yeah,
Right there? There's a programming language called Lisp, which it stands for list processing, but the people say that it stands for lots of silly parentheses. So it's not necessary here. I think it's readable, but if you want to, even better solution would be what we're going to look at next, functions. I would really like if there was a round to cents function, so I didn't have to worry about this every single time. Right? Well, if you want a round to cents function, you can write one yourself, and that's where I would do it. Right? I'll go ahead and leave it like this for now. Let's make sure that it actually worked. Yeah, I'm finally there. $188.71 exactly. And now I'm more comfortable with going ahead and printing it out as a proper number there. Right. There we go. This is kind of an okay piece of documentation here. Right? Why are you multiplying by 100 and then dividing by 100? Oh, that's right. You're trying to round to the nearest cent. Right? There is no round to cents function, so I'm going to document why I'm doing this. This is a perfectly fine piece of documentation here. But if I were to write my own function, then I would move the documentation over to that function. Right? Okay. Make sure I didn't break anything. Still good. Okay. Now, I need to make this loan amortization table. This this table heading here, that's probably just going to be hard-coded, printf, whatever. You want to make it look fancy, you can. Right? Align everything just perfectly so. We can come back and fix that later, though. What I want to make it look like is something like this. I want to print out the month. I want to print out the current balance, the amount that I still owe. I want to compute whatever interest I owe for that month. Offset that by the monthly payment because that's what goes to principal. And then update my balance. Okay? Balance, principal, those sound like two different things. The principal is the original amount that you borrowed. You probably don't want to lose that. Balance, it's what gets updated. It goes from 10,000 down to 9,000, down to 8,000, ... down to 0. You don't owe any more on this. So let me put that into another variable. Balance. I could go ahead and hard code both of these values, 10,000, but why? I've already written it down once. Just go ahead and assign it principal there. So initially it's going to be $10,000. Right? Now I want to go into some sort of a loop. Should we use a for loop or a while loop? We could use either. Right? When do we generally use a for loop? Let's go ahead and review that. When you know exactly how many you're going to go up for, right? Use a for loop when you know upfront how many iterations, say 10 iterations or n iterations, or in this case, 60 months. Right? Use a while loop when you don't know how many iterations you're gonna go. Do not ever take out a loan where we're not going to tell you how many payments you're going to make. Right? That's obviously a scam. Right? For int I equals 0, I is less than what is it? Number month. I put that in a variable so that I could use it. I++. There we go. I like using a for loop here. Right? All right. The first thing I'm going to print out is that month. So let's just go ahead and print that out, printf, and we'll come back and add things to it as we go along here. So %d, there's the month, I. Right? Run this. Yeah. Well, there we go. 0, 1, 2, 3, 4, 5, 6, 7, 8. If you're not, if you remember, I said that was the Champernoun constant. Hopefully you remember that, but if not, there you go. There it is. Right? All right. So not too pretty. Let's go ahead and go end the line. Right? GCC. Run that again. It runs from 0 up to 59. Oh, that's not what I want it to look like. There's no such thing as a month 0 in finance. There's the first month, and then there's the 60th month. So what could I do here? I+1. That's one way. Another way would have been to set it go up to 1, but be careful. Less than or equal to. 6 of one, half a dozen of another. I'll go ahead and go with that. That's fine. Okay. The next thing I need is the current balance. So let's print that out as a number, %2f with a $sign in front of it because, of course, it does represent money. Right? And there's the balance. All right? Once again, if I run this, I see, okay, well, I'm never updating the balance, so that looks right? Because I'm not done yet. Right? I need to reduce the balance. Balance gets reduced by the monthly principal payment. I'm going to put that into a comment, right? Because just to remind myself of what I need to do. In fact, you can be a real programmer and start using the following. To do. Right? Real programmers put these in all the time because, oh, I got to remember I got to do that. So you put in a to do, all uppercase like this, and a lot of IDEs will actually identify it and collect them and formulate a list of things that you still need to do. Never forget it. Once it's done, right, then it goes away. Make sure that you're not leaving to-dos in your finalized code. Right? So balance gets reduced by the monthly principal payment. Okay, so I need to compute the monthly principal payment. Okay, well, what's the monthly principal payment? Right, this is the new balance. This is the principal payment. So what do I need to do to get that? The monthly interest payment. So to do, compute the monthly interest payment. You see what I did there? I'm doing piecewise refinement, if you want to call it that. I'm basically just outlining something. Right? I'm looking at the values that I need from an actual example, and then I'm working backwards. Okay, I need to do this. I need to do that. I need to do that. I can put it all in the comments and then arrange it, rearrange it. I can whiteboard it. I can put it on a piece of paper and rearrange stuff. I can bounce ideas off of my partner. Right? I can clear things in my mind. All right, let's compute the monthly interest payment first. We'll worry about all that stuff later. Right? So if you want to compute the monthly interest payment, right, you probably want to put that into a variable. You could come up here and declare it up here, but why? You're using it down here. Declare it inside the loop. Remember scoping? It only exists for that loop. Right? It doesn't exist before it. It doesn't exist after it. Always limit the scope of your variables as much as possible. This is a great way of doing it. Right? Monthly interest payment. How do I get it? How did I get it over here in Wolfram Alpha? I took the monthly rate times, not the principal because it changes every month, times the what? Monthly, what was it, rate? Times the balance. The balance is going to get updated. I'm not paying the same amount of interest every single month. I'm paying less and less interest as I'm paying this off, right? Any other loans that work any other other ways are scams, right? Payday loans and stuff like that. Right? There we go. In most states, they're illegal now. Right? There's my monthly interest payment. Okay. I need to compute the monthly principal payment, which is monthly principal payment is going to be my monthly payment which I computed up here, and I never change, $188.71, $188.71 for the entire lifetime of the loan, minus what goes to the interest. And again, working from an example like this, you can start seeing the pattern, right? Oh, I need it. Just do it for one iteration, right? These are the variables I need. This is the value I need. This is the value I need. This is the value I need. And then generalize that by giving them labels. Right? Now I need to update the balance. Double, or actually I've already got the balance, right? Balance is equal to the balance minus whatever goes to principal. Is there an easier way that I could have written that? How? Minus equals monthly principal. Oops. There we go. All right. Now let's print all that stuff out. Repeat this because it's money. Money. And it's going to be, what is it? Monthly interest payment. I don't actually print, do I actually print out the, I'm printing out 5 things, I guess. So the monthly interest payment, the monthly principal payment, and then finally the new balance. There we go. Right. There's still a problem here, but we'll fix it. And I need one more of these things. Right, if you want to give yourself some more room here, add some more spaces or whatever, make it look as pretty as you want. Right. Generally, formatting is not going to be an issue on CodePost. We put in what are called regular expressions to ignore white space, to ignore capitals versus lowercase, but the essential stuff that we say has to be there does have to be there. In particular, on your the demo, if you for Lab 1, if you put out I love the School of Computing and then you misspelled school, right? It wasn't going to pass. Right? So spelling does matter, which is why I had to go back and fix all of my misspelling mistakes. Right? Anyway, does that look like what we have here? Let me go ahead and move that up. Well, kind of. $41.67, $147.04, $98.52. Okay, that's right, except for the first column. The first column looks off by 1. Off by 1, off by 1, off by 1. All right? So why? Because I'm trying to print the balance. Then I change the balance by subtracting off an amount that I paid toward it. And then I try to print it out again. All right. Well, just like the, remember when we computed the number of digits in a number, 1, 2, 3, 4, right? I wanted to retain this number over here, 1, 2, 3, 4, so that when I printed it out, it didn't always just print 0. Again, you're not paying by the number of variables. Let's go ahead and create this as a new variable. Double new balance. All right, there we go. And I'll print the new balance over here. Okay. Let's see if that fixed it. Oops. Did I misspell it? No, double new balance. Sorry. It's going to be... how should we do this? Oh, yeah. I meant to do it like this. We will need this variable over and over and over again, so I'm going to go ahead and bring it up here, but I'm not going to initialize it. Let's go ahead and initialize it to balance. There we go. Oops. And there. Take off that declaration. All right. There we go. All right. Well, we certainly did change that first column. Right? The new balance is going down at the end of the loan, except at the end of the loan, I still owe money for some reason. Right? Let's find out why. Well, let's fix that first column first. Right? You can print out the balance, the old balance. You can print out the new balance, the new balance. But what do I need to do to set myself up for the next iteration? Am I ever changing the balance? According to the first column here, no. It's always 10,000, 10,000, 10,000. Right? So, balance is equal to the new balance. There we go. And new balance. Yeah, well, I think that should fix it. Maybe I'm just getting overly excited about making new variables, new variables, new variables. Oops, and now, sorry, what do I need to do? Put it after I print. There we go. Right? Now let's see if that does it. Let me clear this out first. There we go. And jump all the way to the top. Ooh, that looks really nice. 10,000, 41.67, 147.04, and 98.52.96. That looks great. Let's look at the 6th month. 52.63, 38.58, 150.13. Yep, that all looks good. Do you think it's correct? I did not print out the rest of this. There is something missing crucial here. Remember that I rounded the monthly payment? Am I rounding anything else? Nope. Am I rounding that? Am I rounding the new balance? No. I should be rounding everywhere. So let's round the monthly interest payment. Remember, same trick as before, to the nearest cent. There we go. You'd also want to round this. You'd also want to round this. You'd also run around that. 5 times I have to do this over and over and over again. Guess what? Write a function to do it. Put the logic in that function and reuse that function. That's going to be our next topic starting on Wednesday. Right? But otherwise, the other thing I'll bring your attention to is you still owe 16 cents at the end. Right? Remember off by 1 errors, where you might have to deal with the first iteration separately or the second or the last iteration separately. And in this case, you have to, because you might owe just a tad little more than the usual $188.71 in the final month. So whatever your last payment is just your balance plus the whatever interest you owe. Right? But that's the only other thing. All right. We'll pick it up there on Wednesday then.